In this video, we are using the change of base formula for logarithms to answer this question. Our calculator only allows decimal and natural logarithms, but using this formula, we can apply logarithms of any base. Let's prove that changing the base of a logarithm is as easy as dividing logarithms. Well, let's call log base a of x equals m. We can easily convert this into an index so that a to the power of m equals x. Now, taking logarithms of any base b from both sides of the equation, we end up with the unknown m as a coefficient. We can easily make m the subject to prove our formula. Logarithm of x base a can be found dividing the logarithm of x by the logarithm of a. For example, the logarithm of 20 base 2 can be found dividing the logarithm of 20 base 8 by the logarithm of 2 base 8. Why base 8? Well, because we are told that logarithm of 5 base 8 is k, so we want to use the new base 8. Deciding the new base is the tricky bit of changing the base. Once you decide this, the rest is easy. Using the laws of logarithms, we know that the logarithm of the product is the sum of the logarithms. The logarithm of 5 base 8 is given to us, k. The logarithm of 4 base 8 is a bit more tricky. We can always use the change of base formula again to figure out that is 2/3. We can figure out log base 8 of 2 using the change base formula, 1/3. Or you could argue that raising to the power of 1/3 is the same that taking the cube root of 8, which returns 2. Either or, the change of base formula will lead to log base 2 of 20 equals 3k plus 2. If you want to see more videos about logarithms, feel free to click in either of those videos. Until next Wednesday, happy learning!